Well, here we're looking at the first of our lecture series, and this is the steps of the scientific method. The scientific method is used for all sciences, and you probably are pretty familiar with this, but we'll run through the different steps. The scientific method involves a series of steps that are used to investigate different occurrences. Uh, You may even use them, it says natural on the slide here, but you might have used them, an automobile mechanic will use a scientific method to determine what a problem is with an automobile. Or sometimes, where's my car keys? You might use a scientific method just naturally to determine where you left your car keys. So the next few slides will look at what these steps are. First one is the problem or the question. Then we're looking at observation and research, formulate a hypothesis or an education guess, experiment, collect and analyze the results, form a conclusion, and then we need to communicate the results. The problem with question, that could be the hardest part sometimes of the scientific method, is to come up with a good question that can be solved through experimentation. And so that is the first step we need to look at. Step number 2, make some observations and research your topic of interest. These observations could be any type of observation, visual, do research over the internet. But you got to collect some background on what you're trying to investigate. The next one is to formulate a hypothesis or an educational guess. And probably through your science classes, you talked about this one before. And you're looking for a possible answer to the problem or the question. Example here is if soil temperatures rise, then plant growth will increase. And that would be your hypothesis. The next step, you're going to experiment. Develop and follow a procedure. In science, you need to follow procedures as you go through the experimentation phase. Typically, when you put an experiment together, you need some materials. And the outcome must be measurable. In other words, you can quantify it, put numbers with it. Just to say, well, I think this will work, really doesn't hack it in the scientific community. The fifth step, collect and analyze the results. So as you go through the experiment, you'll collect them, you'll look at your results, and you might have to modify the procedure if needed. You may have found that you've done something wrong as you went through your experiment. Quite often you just can't just do one test to confirm your result. You must retest it. Usually when you start collecting and analyzing results, you'll have some type of table, a graph, and or photographs. We'll be doing tables and graphs pretty extensively in the class this year. The sixth step, you're going to draw a conclusion. And from this conclusion, it's either going to reinforce your hypothesis or you're going to find out you're way off base. And also at this point, you might make a recommendation to study whatever you're looking at further, and also things I could have done different to improve what I was testing. And another step, or step 7, communicate the results. This could be a lecture, it could be some type of audio-visual presentation. In real scientific research, you'll probably present a paper in some scientific journal. Here it says John watches his grandmother bake bread. He asks his grandmother what makes the bread rise, and she explains that yeast releases a gas as it feeds on sugar. And so John wonders if the amount of sugar used in the recipe will affect the size of the bread loaf. And again, here's a little bit of English, so we'll cover a little English on this one. Effect is a noun and affect is a verb. The observation research here. John researches the areas of baking and fermentation and tries to come up with a way to test his question. And again, he keeps all his information on this topic in a journal. And again, detailed note keeping is important on this. Nothing should go by. Write everything down. John talks with his teacher and she gives him an experimental design diagram. And on the next slide here, this is one possible way to put up an experimental design diagram. And after talking with his teacher and conducting some research, he comes up with a hypothesis. And his hypothesis is if you add more sugar, then the bread will rise higher. And again, the hypothesis is an educated guess about the relationship between the independent and dependent variables. And we're going to look at the independent and dependent variable in the next couple of slides. The independent, and another term for this is a manipulated variable, is a factor that's intentionally varied by the experimenter. And this on a graph will go on the x-axis. Typically, time will be the independent variable. It is something that you control, that you set, and then you measure something against whatever you set it at. And here, John's going to use look like increments of 25 grams. That actually looks like he's doubling the amount of sugar every time in his experiment. The dependent variable, or the responding, is the one that changes as a result made in the independent variable. The dependent variable is typically shown on a graph on the y-axis. So it's what you find. It's kind of your experimental data. If I'm going to use 25 grams of sugar, how high is my bread going to rise? And for this particular scenario, you're looking at the size of a loaf of bread. And then your teacher helps them come up with a procedure and a list of needed materials. And she discusses how to determine the control group. In most times in an experiment, you get a control group that serves as a standard of comparison. Quite often in drug testing, you'll hear the term placebo, and this is typically a sugar pill, and they'll compare the results of some type of drug to the placebo. The control group may be a no treatment or an experimenter selected group. And the control group is always exposed to the same conditions as the experimental group, except for the variable being tested. And really, you can only test one variable at a time. When you start testing two variables at a time, that really gets quite messy. And all experiments should have a control group. And this particular one, because his grandmother always used 50 grams of sugar in his recipe, John is going to use this amount in his control group. Constants, and again, John's teacher reminds him to keep all other factors the same so that any observed changes can be attributed to the variation in the amount of sugar. Now again, only change one thing at a time. Keep everything else constant. For bread, the amount of flour, the amount of water, the amount of eggs, what have you. And again, constants are things that you want to keep the same. And in this particular example, the oven, the time that you're cooking, ingredients, the temperature and humidity, the oven temperature, age of the yeast. There are many different variables that you would want to control. The experiment, John writes out a procedure along with a list of material in his journal, and again has these checked by his teacher. Trials refer to replicate groups that are exposed to the same conditions. How many trials are you going to perform? 1, 2, 3. Again, it depends what type of experiment, a number of trials you're going to use. And John's going to test each sugar variable 3 times. Then he comes up with a table. Typically, you can do this in an Excel. Would be using a lot of computer work here to record your data. And here's an example of a Excel spreadsheet here, and the number of trials, and he measures the average size of the loaf of bread. And again, the loaf of bread would be the length times the width times the height. He collects and analyzes the results, and he notices his control worked the best in this experiment, but not significantly better than 100 grams of sugar. So in his conclusion, he rejects his hypothesis, but decides to retest using sugar amounts between 50 and 100 grams. And then once again, he can go through that whole procedure. And here's the results of his second experimentation. And his conclusion is that 70 grams of sugar produces the largest loaf. And his hypothesis is accepted. And it's another TRS production.